So 802.11 comes in a lot of different standards, and what we're looking at here is, of course, what is my total speed, my bandwidth if you would, what are the frequencies in which that it operates on, and what do I need to plan for. Now, there are these popular standards that we see all the time, the 802.11a, 11b, and 11g, and you might ask, what are all those differences? Well, a lot of it is that frequency range that we're using and the speed that we can operate on. Unfortunately, the frequency in which these wireless networks are operating on can be used by many other technologies, including your cordless telephone. So we automatically have a bit of a problem with our wireless networks just in a denial of service arena, because there's so many other things that can operate at that frequency and can cause interference. Now, when you're setting up your wireless local area network, one of the things that we have to do is come up with this service set identifier, this SSID. We have to configure that information so that we have a way of identifying this network. Whether or not you set it up, most of your access points are going to have some default setting. You know, if you're a home user, you're going to be setting out this SSIDs like Linksys and D-Link or any of these others, and I would seriously suggest at home, don't use those default settings. It's easy for a hacker to drive around, find that setting, and then go after it, because they're going to assume if you stuck with the default SSIDs, then you probably have the same default passwords. Now, all it is, of course, the SSID is an alphanumeric string that lets us be able to identify this network over this network. A little bit later, I'm going to show you a simple little tool, a PDA, that can go out there and sniff wireless networks and help you discover them, and it will tell you about all of the SSIDs that it finds. Now, when we talk about this SSID and this unique identifier, some people might say, well, that kind of sounds like maybe it's a password to get into your network. And well, you know, it's not quite a password. You're usually beaconing or broadcasting that information out. I intercept it because I'm listening, and I say, oh, I'll use that network. So there are some concerns about that, and some of the things you might consider, of course, is to make sure that you're not actually broadcasting that SSID, so that if I'm out there trying to search for your network, if I don't know the SSID, I'm not going to hear from you. Unfortunately, if this network's already communicating and I can detect those packets, then I'm going to start getting information about your network. But it's just one more step to try to secure the information to secure that wireless network. So another thing we did is we looked at, what if you do sniff my network, can we encrypt those packets that you're getting? And originally we came out with this wireless equivalency protocol. And what we're trying to do here is find a way to create an encryption scheme so that if you did get this information, that all you got was encrypted garbage, and by the time you finally did crack it, well, it'd be too late. You wouldn't need that information. Unfortunately, WEP had some logical flaws that if I were actually able to get these interesting packets, these initialization vectors, and capture enough of them, I could, with enough time or enough packets, crack your encryption key and then be able to have complete access into your network. Typically, we talked about programs like ErrorSnort that would capture these packets, look for those interesting packets, and within 5 or 10 million of these packets, it had your encryption key, and your network was now vulnerable to me. Other things that we do, of course, is going out there and sniff for these MAC addresses. We want to see what we can get, so maybe I can spoof who I am to your network trying to get in. Other things that happen is this access point spoofing. In this situation, I might come into your company with my own access point set up with the same SSID as your company, with the hope that your users are going to connect to my access point so that I can get all of their information and maybe still be at man in the middle and try to continue to send that information on. It's also getting very common that a lot of people are doing the very same thing at a lot of these coffee shops, where you might go in and have these hotspots, if you would, and you want to log in and surf the internet while you're drinking your coffee. Well, all it takes is somebody to come in with their own access point, sending out a stronger signal, trying to impersonate the same network with the same SSID. You make that connection, And they go through the whole authentication protocol for you. They send you that sign-on page where you provide your credentials, you log in, put in your credit card numbers, ask for access, and now you've just been basically spoofed by an access point and gave all of your financial information to somebody who shouldn't probably have it. So again, there's a lot of things that are going on. I'd be careful about what you think you're signing in on, because it's getting easier and easier and easier to spoof an access point. Now, along that same line, if I can spoof that access point and pretend to be that network, couldn't I also do something else with those frequencies to try to do a denial of service? And of course, I certainly can. One, I could just use my cordless phone and possibly cause problems. But again, other things I could do is trying to continue to set out these access or these collision avoidance packets, is trying to get the access point to say, okay, your traffic's next, your traffic's next, making sure that nobody else can get connected, or if they do, it's really slow. So, you know, radio frequency, frequency type of attacks to cause a denial of service, sending out packets to the access point, trying to keep it busy, all things that I can do as a denial of service against your wireless network.